Hello, class. Excuse me. This will be the video for section 5.1, graphs of polynomial functions. Um, this is, just warn you now, this is one of maybe the longest sections of the book. Yeah, so even though we're only doing 4 sections this chapter or this unit, there's probably almost 2 units, 2 sections worth of material here. But on the flip side, I could probably do 5.2 in the same section because 5.1 is mostly, different ideas, and then 5.2 is all those ideas put into one problem. Right. So just like towards the end of 4.3, when you had all those like multi-part problems, that's what 5.2 is. So I don't, off the top of my head, I can't remember of any new material in 5.2 because there's so much material in 5.1. I'll try to watch the time, and I may have to split this into 2 parts. We'll see. Okay. Right. So the topic for today, with graphs of polynomial functions is, we in 4.3 we focus on just parabolas on the quadratic functions, which are degree 2. Now we're going to talk about degree 2, degree 3, degree 4, and so on. We could get really big degrees potentially, but with what we're doing, we're finding a lot of x-intercepts, and so we're really going to keep most of the degrees around 3 or 4 or 5. Um, but theoretically, we could do a lot bigger. So the core idea of 5.1 is by the time we're done, we need to be able to graph these polynomial functions. There are 2 main parts to that. One is what we call the end behavior of the graph, which the end behavior is at the left and right ends of the graph. So as x goes to negative infinity, what's happening on the far left? As x goes to positive infinity, what's happening on the far right? And so that's what we call the end behavior. Turns out that's mainly on degree. Well, it's solely on degree and the leading coefficient. And we'll get to that. So that's sort of the half of the graph is what happens at the ends. Then we also need to talk about kind of what happens technically in the middle. And so when we get into the middle of the graph, that's when we're going to talk about the x-intercepts. And not only where are the x-intercepts, but like the behavior of the graph right around the x-intercepts. So in a nutshell, that's 5.1. However, to do all that, there is a lot of related topics. And then you talk about polynomial notation, and so there's just a lot going on with 5.1. Okay, so I'm just trying to warn you now. This will be one of the longer homeworks and longer videos. Just there's a lot to cover. All right. So as always, I have the notes posted in Blackboard for the lecture outlines. So let's get into notes and see what we're talking about. All right, so first part of this is we're going to review some of our notation and vocabulary with polynomials. We may have talked about this back at the beginning of the semester, but it's worth repeating. So when we talk about polynomial functions, the general form is this a sub n, x to the n, a sub n minus 1, x to the n minus 1. Those are just, the a sub n's are the coefficients along with each x. And so to have a polynomial function, we can only have positive whole number exponents for our x's. So x squared, x cubed, x to the first, constant, constant is basically x to the 0. We can't have negative exponents. We can't have, because if you have negative exponents, we talk about this, that's a flip. And so that's where you're going to be dividing by that x. That's rational functions, and we'll talk about those at the end of our unit 3. We can't have things like fractional exponents, because fractional exponents, in case you remember, those give us radicals, and we can't take the radical of x. It's not a polynomial. What else? Those are the main ones. You can't have negatives, or you can't do other things like take absolute value of your x. You can do anything you want with coefficients, but the x's can only have positive whole number exponents. And then for the degree, Remember, the degree is if it's written out in this form, the degree is the largest exponent. We are going to have some of these in factored form, and we'll talk about how to find the degree then. But the degree is kind of gives you the overall shape. So that's the degree is important. And then the other thing is the leading coefficient. Remember, the leading coefficient is that coefficient that is wherever we get the degree from, that's the leading coefficient. So if this is not in descending order, like if we got the degree somewhere in the middle, then make sure that that coefficient, positive or negative, is your leading coefficient. Okay? And A sub n is the abbreviation for leading coefficient. So if you see me using that, that's a lot quicker to write than leading coefficient. All right. So let's see. We talked about, so I talked about this already. So to graph polynomial, we are going to do something called the leading coefficient test. That'll tell us the end behavior. That's what's tell us what's happening in the left and the right of the graph. And then we're going to do a lot of work with the x-intercepts. X-intercepts are also called roots. We're going to talk about something that's the multiplicity of each root, which the multiplicity, when we're doing roots or x-intercepts, since we're setting these equal to 0, this goes back to when we were solving equations by factoring back in test 1, when you had something like, I don't know, f of x equals x squared minus 25, and we said set that equal to 0 and solve. Well, when you're setting it equal to 0, you're saying y is equal to 0. So if y is equal to 0, we're doing x-intercepts. So this connects to stuff we've been doing way back in test 1. And the way how you would solve that is you would factor it. So x minus 5, x plus 5. And then you would set those equal to 0. Well, that's what we're talking about, these factors. That's coming from solving by factoring. Okay. Now, when we did it, most of the time we just had an exponent of 1. Now we're going to get, it's not always going to be an exponent of 1, and that multiplicity is just the exponent on those factors. Okay. We'll talk more about that as we get deeper in. Okay, but once we get the multiplicity, that's going to tell us a lot about the behavior of the graph, and so we'll come back and talk about this later. I'll skip that for now. And then, you may ask for x and y intercept, we're going to find x-intercepts constantly in this section. May occasionally find a y-intercept, but just like with parabolas, with the y-intercept, you just plug in x equals 0, so it's a much more straightforward thing. All right, some other vocabulary. All polynomials are what we call smooth and continuous. If you're going on to calculus, there's a much more rigorous definition of what those mean. But for us, smooth means no sharp corners. What do I mean by that? Think of absolute value. All right, so absolute value's got that V, so right there at the bottom of the V, that's a sharp corner. So absolute value graph is not smooth. And then continuous. Continuous means, for us, that means you don't need to lift your pencil to draw. So the examples that we have of something that's not continuous is most of those piecewise functions we did, when we went from like the left to the right, unless they happened to connect at the same point, you had to lift your pencil to draw one side or the other. Those were not continuous. We also talked about 1 over x. That 1 over x had a graph that looked something like that. We didn't really talk about a whole lot, just barely mentioned, but we'll see this again in 5.3. But to draw this piece to this piece, you have to lift your pencil. And so that would be not continuous. Okay, so all polynomials, you can draw them without lifting your pencil, and there's no V's and no sharp corners. All right. So the homework starts out. One thing about the homework, like I said, it's been a little bit since I've looked at this homework, and as I was going through the notes, I was like, a lot of these homework questions are a little bit out of order. I don't think it flows as well as I would like. So if you are going through there, and like multiplicity gets mentioned early in some of the definitions, so if something feels out of order in the homework, just skip it. and you'll come to it a little bit later. It's just I would have fixed it, but somebody was ambitious and already started this 5.1 homework. And as soon as a student starts a homework set, then I can no longer make adjustments to it other than like taking out questions. So I couldn't fix the order for this semester. But just be aware that some of those questions in the homework may feel like they're out of order, and it's not you. That's me when I made that homework a year ago and haven't fixed it since then. So I apologize. All right. So basic questions. And so is something a function, or sorry, is something a polynomial? When you look at this, is that a polynomial? Well, it has that fractional exponent, so no. Okay. What about number 2, 4x plus 6x squared? Okay, so we're not doing anything weird with our x's, so yes. Okay, what about 3? The fourth root of x to the fifth minus x to the sixth minus 8. Well, we can't do anything with radicals on their x. And actually, I know this is, yeah, this is actually another way to write x to the 5/4. We very briefly mentioned that way back in, was it R8 on test 1? We'll see that again in logarithms, but no radicals, no fractional exponents. So, and then if you look at number 4, is that a rational function? Well, there's no fractional exponents, there's no radicals. However, we do have a divide by x. Yeah, and that's equivalent to x to the -1. You remember, flipping our variables. And so because of that, that is not a function, or sorry, not a polynomial. Okay, so the only thing we can do with our x's is have positive whole number exponents. Okay. All right. So we started the semester with questions like this, but now we're, degree and leading coefficient are really important in 5.1. And so that's why we're giving you these questions again. So for number 5, f of x is equal to 5x minus x to the fourth plus 5/4. What is the degree and the leading coefficient? Well, the degree is the largest exponent on our x, so it's 4. And then the leading coefficient, which again, I'm going to label as a sub n, is the coefficient on the degree, the term that gives us the degree, to be -1. So remember, if it's not in descending order, then you got to be a little bit more careful with it. What is the degree and leading coefficient on number 6? -12x minus 7. Oh, the degree is 1 because it's x to the first. Leading coefficient is -12. We're not gonna, and this is a line, so even though it's a polynomial, it's a straight line, so we're not gonna deal with straight lines in this section because we already dealt with them back in chapter 2. They don't have the fun curves like x squared and above do. All right, so how about number 7? Is that a polynomial? So this this one is what we call in factored form. So notice that it's not like x squared plus x fifth plus x sixth plus x the fifth. It's got these factors. And so whether or not this is a polynomial, the same thing still applies, is we can't have negative exponents, fractional exponents, no absolute value. And so this is still a polynomial. Because we're not doing anything weird with that. And if you think about foiling this out, you'd have x minus 1 11 times, you'd have x plus 1 9 times. If you FOIL all that out, you're going to get, a big messy polynomial, but still going to be a polynomial. Now here's where you have to be careful. Okay. So if I ask you for the degree, what would you say? So in class, the most common answer I get on this is 11. So if you're saying the degree is 11, then you're good up till what we've covered so far, because we've said the degree was the biggest exponent. But that's only applicable if it's in written out form. So if it's in that form, then the largest exponent is the degree. If it's in factored form, oh, hope you didn't read ahead. You got to cheat. So if it's in factored form, you must add all the exponents of the factors to get the degree. Now, the factors with x. So that 6, it has an exponent of 1, but there's no x with it, so we ignore it. So the factors that have x, there are 11 plus 9, so the degree would be 20. And like I said, if you think about foiling this out, there's 11 of these x minus 1s, there's 9 of these x plus 1s. So by the time you FOIL it all out, the biggest one's going to have x to the 20th. Okay. So what about number 8? Is that a polynomial function? Yes, it's a nicer version of number 7 because you think about distributing that, that's going to be x squared minus 12x. So yes, it is a poly. And then what's the degree? Well, there's 1x here, 1x there. Or if you think, or like this one we can actually distribute, unlike the top one. That is x squared minus 12x, so you're going to have an x squared. Okay, so what about 9? Is 9 a polynomial? Well, it has a polynomial on top and a polynomial on bottom, but we're dividing by x, so this is not a poly. Okay, because you can't have a division by x and it be a polynomial. It's a rational function, which is fine. And again, that's what we're going to do in 5.3, but we're not there yet, so we're just talking about polynomials. Okay. And so since it's polynomial, we're not going to bother asking the degree because it's kind of a nonsense question if it's not a polynomial. Okay. So again, that's just kind of warm up. So let's go through. There was something about turning points. Oh, well, let's just go through my notes. Okay, so when we're graphing these polynomials, again, we're graphing degree 2 or higher polynomials because lines are degree 1 polynomials. We've already, covered that. Okay, and no, this is like the third or fourth time I said this, so I'm really trying to make this point. To graph these polynomials, we need to know the end behavior. So what's happening to the far left and the far right side of the graph, what's happening in the middle, basically where are the x-intercepts and what's happening around. The program I use has columns and a lot of times it cuts them off if I'm not careful. All right. This one is going to be the x-intercept stuff is a little bit longer discussion. That's newer stuff. And so we're going to hold off on that for now. Now, when it comes to end behavior, I'll say there's like 2 families of graph shapes. And so if you have x squared or any even degree, so x to the 4th, x to the 6th, and so on, it's going to be the parabola shape. Okay. If you have x to the x cubed or any odd degree, it's going to be the S shape. Okay. So those are the 2 general shapes that we're going to be dealing with. Okay. My program doesn't have a spell checker either, so. Okay. All right. So as degrees get higher, so like for I just said like the even degrees are going to have the parabola shape, but as you get x to the 4th, x to the 6th, 7, 8, and same with the odd degrees, you could get 5, 7, 9, whatever. We could get more turning points. And what turning points are in our vocabulary are just maxes and mins. Because and the reason they call them turning points is that's when the graph goes from increasing to decreasing or decreasing to increasing. Right? We just didn't call them turning points back in chapter 3, but that's another word for our maxes and mins. Now, I don't know if it comes up or not, but the maximum number of turning points is always a degree minus 1. And the easy example there is if you have x squared, how many maxes or mins going to have? Well, only one, right? Depending on if it's upward or downward parabola, it would be a max or a min. But x squared can only have that one turning point. Okay, and so 2 degrees 2, 2 minus 1 is 1. So an x cubed could have 2 turning points or 2 maxes or mins. An x to the 8th could have 7 turning points. So that means 7 maxes and mins. And so when you get more turning points, basically what can happen is then you start looking like a W, or you could, if you get really high degree, you get a lot of maxes and mins. So but it takes a lot more higher degree to be able to get something that fancy. The other thing that could happen is as the degree get higher, instead of having a lot of maxes and mins, they could just get flatter around the middle. So instead of almost like a V-shaped U, you could get something that's almost flat. So that might be something like an x to the 6th or x to the 8th. So in the middle, it could also get really flat instead of getting wavy. All right, but still, it's all even degrees are going to have that basic, the basic parabola shape, all odd degrees. Like this would be an odd degree because even, if you cut out the middle, that is your S shape. Now, before we get into the end behavior, we're going to talk about transformations right quick, because that's something we've already covered. And so this is kind of a connection between the two topics. And so just as a note, all transformations are still working the same. So we're still talking, inside the parentheses with the, inside the parentheses, that's horizontal. Outside is vertical. To do a shift, left, right, up, or down, we're going to be adding, subtracting. Remember, vertical stuff works as normal. Horizontal transformations are always backwards, what you think. And then if we want to flip it, to make that upward parabola a downward parabola, or that upward S shape a downward S shape, then we need a negative, like if there's a negative on the outside, that would be a vertical flip, up and down. Okay. All right, so let's go through here and just do a couple quick transformations. And so we have x cubed, x minus 5 cubed. And so we didn't have x cubed, x to the 5th as one of our basic functions. But treat any odd degree like an x cubed. So our base function, think of x cubed. Okay, so that's what we're dealing with. Now, being x to the 5th, it's going to be steeper. And so you notice those are a little bit more vertical. That's why it's more vertical than the x cubed, but it's still the same basic shape. Now, I know these graphs are small, but what is the transformation that's been done? So it's inside, so it's horizontal. Horizontal is backwards, so he initially thinks it might move left, but -3 was to the right. So we're looking for this basic shape that went right 3. So even though that's very small, to me, it's pretty obvious that has been moved up. Because remember, we're talking that 0, 0 point. That's been moved up. We don't want that. Let's see. B has been moved left. So we don't want that. C has been moved down. So we don't want that one. And then finally we get to D. D is definitely been moved right. And then that's too small, but that's the only one that's been moved right, 3. So it had to be D. So this transformation stuff works exactly the same, but just if it's an odd degree, treat it as x cubed, S shape. If it's an even degree, treat it as your parabola. Okay. All right. So originally I had like all these on one page, and so something happened that moved my printing off, and it's annoying me. So I had it all nice and like I wanted to. All right. So how about the next one? So we're doing x to the 4th. So x to the 4th is going to act like x squared. So our basic shape is going to be an upward parabola. So we have a -2 to deal with. We have a +5, and we have a +3. So So what is that minus 2 do? Well, ignore the 2 for a second. What does the negative do? Well, negatives are flips. And so is that a horizontal flip or a vertical flip? Well, it's outside the parentheses, so that is a vertical flip. And what the 2 does is we talked a real brief about strengths and stretches. So all that 2 does is it makes it wider and narrower than normal. So the really important part is the negative. The negative is going to be the vertical flip. All right, so what does that plus 5 do? Well, it's inside, so it's horizontal. So positive 5 moves it to the left 5. And then the plus 3, that's outside, so it's vertical, so it's going to go up 3. All right, so we need to find which one of these it is. So definitely can't be A, because that's an upward parabola, so it's not flipped. And where is D? So if you look at D on the next page, also can't be that because it's not flipped. We need a downward parabola. All right. So now we've got it narrowed down to B and C. So which one of those has been moved up 3? Well, they both have been moved up 3. That doesn't help. Now we need left 5. Well, that one's been moved right 5. That one's been moved left 5. And they have both been vertical flipped. But now they're downward parabolics. All right, so we'll C will be our answer. Okay. So that's kind of what you're going to have to do with transformations. Again, it's nothing new in terms of the actual transformation. It's just now, instead of dealing with x squared and into the third, we're going to be dealing with, 4, degree 4, degree 6, so even degrees or odd degrees. But so if it's x to the 5th, treat it as x cubed. X to the 7th, treat it as x cubed. Other than that, transformations are still what we've been talking about. Right? So that is sort of the warm-up to the graphing of the polynomial functions. Good. So now let's more formally talk about it. All right. So we have what we call the leading coefficient test. And so for the leading coefficient, you need 2 items. So what 2 items do you need for the leading coefficient test? Well, one is the leading coefficient. Okay. I was looking for that in my notes. Okay. So we need 1, we need the degree. And 2, we need the leading coefficient. Okay. All right. So the leading coefficient, we're going to come back to that wording. So if the degree is even, okay, then we're going to have a parabola shape. If degree is odd, we're going to have an S shape. So that's why you need the degree, is which one of those 2 is it. And then the leading coefficient tells us if it's up or down. Because if the leading coefficient is positive, it's upward. The leading coefficient is negative, then that's a flip down. So it's a downward. The leading coefficient is negative, that tells us it's down. So here's how I summarize this. We're going to get into the language here in a second. Let me graph these. So what I like to do is I like to do a little chart with 2 big areas. And so we're up here, let's do degree. So we're going to have even degree and odd degree. And then for the columns, let's do the leading coefficient. So top row is going to be positive leading coefficient, bottom row is going to be negative. So if we have an even degree, so that tells us we have a parabola shape. And so if the leading coefficient is positive, it's an upward parabola. Now I'm going to put dot, dot, dot in the middle because we don't know what's happening there, because we talked about the waves and the flatness. So we're just talking about the end behavior. What happens on the left, what happens on the right. We have an even degree with a negative leading coefficient, so that upward parabola gets flipped down to a negative or a downward parabola. Okay, if our degree is odd, like x cubed, then we have an S shape. Again, I'm going to put the dot, dot, dot in the middle. So that's our positive leading coefficient. We have a negative leading coefficient, that's a vertical flip. So the downward part gets flipped up, the upper part gets flipped down. This right here is the key to all of these in behavior problems. No matter how they ask it, this is what you need to know. This is the most important part of this. Now, how we answer it depends on how they ask it. Okay, so one of the ways that we can do is, if you notice up here, it talks about rising and falling. So like on here, what would you say is happening on the ends? Well, both sides are going up, so we would say rises on both sides. So if we're using the rise and fall language, what would you say about a downward prep? Well, it falls on both sides. Okay. So now that we, so that's our even degrees, x squared, x to the fourth, x to the sixth. So how would you use fall and rise language for an upward S shape? Well, on the left it falls, so it falls on left. And then rises on the right. So I think you got the idea now. So for this one, it rises on the left now. And then falls on the right. Okay. So if you see the rises and falls language, they're talking about what's happening with the y values. Okay. And anytime you have a graph and you're trying to figure out like information about the polynomial, if the ends go in the same direction, if they both go up or both go down, you know you're dealing with an even degree. 2, 4, 6, 8, and so on. If the ends of your graph go in opposite directions, either up, down and up or up and down, now you know you're dealing with an odd degree, 3, 5, 7, and so on. Okay. And so that's, to me, this is the more of the college algebra way to describe this. But part of this class is pre-calculus, and so there's the calculus way to answer this as well, and you're going to see some of those problems in the homework. And so let's look at those as well. So the calculus way to ask this question about in behavior is up here. Okay. Now, sorry, that's kind of small, but that is x goes to negative infinity. So if x is going to negative infinity, what does that mean your graph is doing? Well, negative infinity for x is to the left. So this says as x goes left, then remember fx is y, so what is happening? So that arrow means goes to or approaches, so as x approaches negative infinity, then f of x approaches what? Okay, so this is your y value. And so we're going to say either, if we're going up, you're going to positive infinity on the y values. If you're going down, you're going to negative infinity. Okay, so these are in this language, f of x is always either going to positive or negative infinity, depending on what's happening with your y values. And then the other way is x approaches or goes to infinity, so positive infinity, that means you're going to the right. Then f of x goes to where? So again, is f of x, is the y value going up or down? And that depends on the degree in the leading coefficient. Okay. Let's go through some of these with this language, and then I think this will be a good point to stop and bring up MyMathLab before we get in and work on some of these before we get into the zero stuff. Okay. So use the leading coefficient to determine the end behavior and then sketch it. Okay. So 3x squared plus 2x minus 2. So how do we know what the end behavior looks like? Well, we need the degree and we need the leading coefficient. So what is the degree? Well, the degree is 2. So what's important about that is that it's even. What's the leading coefficient? Well, that is the 3 that's there in front of the x squared. What's important about that is not that it's odd or even, but that it's positive. So if we have an even degree polynomial with a positive leading coefficient, which one of those 4 shapes is it? Well, even says it's parabola, leading coefficient positive, saying it's an upward parabola. So the first thing I do before I do anything else is I do that little sketch. And by having that sketch, particularly if you're a visual learner, I think it makes it easier to answer in the calculus format. So as x goes to negative infinity, so as x goes to the left, what is y values doing? So as we go to the left, y values are going up, and they're going up to positive infinity. Now, as x goes to infinity, so that means as x goes to the right, so as we're going to the right, what are the y values doing? They're going up, and they're going up to infinity. So if your degree is even, these should be the same answer, because you're either both going up or both going down to negative. Good. All right. So how about 15? Same question. What's the end behavior? So we need the degree, and we need the leading coefficient. And again, it's always nice when these are in descending order, because the degree is 3, leading coefficient is -3. Okay, so what does that tell us? Well, we have an odd degree, a negative leading coefficient. So what does odd tell us for degree? Odd tells us we're in the S shapes. Which one of these do we have? A negative, so we have a downward S. Again, sketch that in. And now I think that makes it easier to answer this question. So as x goes to negative infinity, so as x goes to the left, then the f of x and the y values, as we go to the left, y value is going up to positive infinity. As x goes to positive infinity, so as x goes to the right, then f of x, the y values are going down. They're going down to negative infinity. All right, number 4, that middle one should be x to the 4th. So what's the degree? Well, the degree is 5, because that's the largest exponent. What's the leading coefficient? Well, in front of that term is a negative, so it's -1. We got an odd degree, negative leading coefficient. So we're in that same shape, right? So that's an S shape, that's a downward S shape. So as we go to the left, y is going up, positive infinity. As we go to the right, y is going down to negative infinity. All right. Then same idea. So let's do 4, which is even. The coefficient is -4, so that's negative. So even degree says parabola, negative says downward parabola. So what are the y values doing as we go to the left and to the right? They're both going down to negative infinity. Yeah, so that's one way to talk about end behavior. Okay. Now, in my notes, the next thing is going to talk about the zeros or the x-intercepts. So let's pause this for a moment and get into MyMathLab and see how these questions are before we get into the degree. Sorry, before we get to the x-intercepts. All right, so this is 5.1. So not only does it have a lot of questions, but like I said, there's a lot of stuff going on in 5.1. All right, so it starts off by, is this, oh, sorry, it didn't share properly. All right, so question number one, is this a polynomial? And if so, what's the degree? Now, if you take just a quick glance at this, you might be tempted to say, no, it's not a polynomial because of the square root. But remember, it's the x's that matter in the definition of a polynomial. So x, we have x to the third, x squared. That square root is just on the number. So that constant, we don't care that there's a square root on that. There's not a square root on either x. Those are both positive whole number exponents. So yes, it is a polynomial. And what's the degree? Well, the degree is 3. The graph of every polynomial function is both, well, it can't be straight or linear because those are lines, flat. Those are all different ways to say lines, which lines are polynomials, but the real question here is they're smooth because there's no sharp corners, no V's, and it's even and odd. We don't care. The degrees can change, but we do know they're continuous because that means we can't lift our pencil. All right. This is talking about multiplicity. We haven't talked about multiplicity yet, so that's what I said. Some of these homework questions are out of order, so I'm going to skip 3. The points at which a graph changes direction from increasing to decreasing or vice versa. Well, you might want to say maximum or mins, but it's both of those together. So what we're talking about here, when we're talking about changing direction, those are, it's not changing. Changing points might be the English, but it's turning points. So turning points are where we change direction. Now those are maxes and mins, but the official name of the point where we change direction is a turning point because it can be max or min. All right, so this is one where, what we just did. All right. And so notice, so if f of x is negative 3x to the fifth plus x cubed minus 6x squared plus 9, then f of x goes to blank as x goes to negative infinity. So notice they don't ask about the end behavior here. But the only time we're going to use this type of language in our problems is where we're talking about end behavior. So and I kind of wish they would put the as x goes to negative infinity first. But as x goes to negative infinity, so as x goes to the left, what are the y values doing? Well, to know what the y values are doing, we need to know what the end behavior is. Okay? So we need the degree, which is 5. So that tells us S shape. It's a negative leading coefficient, so it's a downward S shape. So as we go to the left, we're going up. So since we're going up, the y values are going to positive infinity. And then as x goes to positive infinity, going to the right, it's a downward S. So it's going down to negative infinity. And like I said, if you're a visual person, I would highly recommend putting that little sketch of that downward S or upward or downward parabola before you answer these questions. I do think that makes it more straightforward. Okay. So we're talking zeros yet. So again, this is one of those that's out of order. So anytime we're talking about x-intercepts or zeros or multiplicity, that's the second half of what we're going to discuss. Okay. Determine whether or not the following function is a polynomial. If it is, state the degree. If not, why not? And then, as you know, when MyMathLab tries to define stuff, that can be a bit messy. And then identify a leading term and a constant term and write it in standard form. Okay. So is that a polynomial or not? Well, x to the first, x to the cube. So yes, it is a polynomial. And then the degree of 3. Okay. That's the only one that makes sense. All right, so now what do they want us to do to it? Put it in, now what do they say when it's in standard form? Standard form means in descending order. Okay, so is this in descending order? No, because we need the x cubed first. Remember when you're rewriting this, put this in descending form, don't lose your negative signs, keep your signs with that. So in standard form, this is going to be x cubed and then plus 4x, so plus minus. With a leading term, and so the leading term is the x cubed. So the difference between the leading coefficient and the leading term, the coefficient, it would, if it said leading coefficient, it would just be 1. Okay, because that's the coefficient on x cubed. Since it's a leading term, it's the whole thing. So it's 1x cubed. Now for the constant, there isn't a constant. Okay. I'm going to take a guess here right quick and see. Right, so the reason I'm hesitating is there is no constant term in here. So what are they wanting? So here's how I would do this. When this isn't making any sense, go to the example. Okay, so let's yeah, so they're going through great detail on that. So in standard form, yes, we're putting it in descending order. All right, so that's good. Oh, must be getting a little tired. So remember when I said there's no constant term? When I tell you don't treat 0 as nothing? Okay. This is why those examples can be helpful. See, I've been doing this for a long time and I still make mistakes. Because I was looking for the constant in there. That's sort of like when we did y equals mx plus b and there was no, plus or minus anything. B was 0. Okay. All right. See, even math nerds can make mistakes. So, all right. Determine whether it's a polynomial or not. Why? Oh, okay. This is the next one. Okay. So again, the same idea. This is x to the first, so it will be a polynomial. It's degree 1 because it's x to the first. And then you put it in descending order. Make sure that when you put it in descending order, you say negative 1/5 x plus 4. All right. Is this a polynomial? No, because we're dividing by x squared. Or remember, no, the only two choices, it's not a polynomial, so the only choice here, which is, so if you want to say 2, which would be a natural thing to say because that's the power, notice they're saying it's incorrect. So why are they saying 2 is not the answer? All right, because really, when you're dividing, you can flip that up, and it really should be negative 2. That's what, when you're dividing by x squared, that's what that means. And again, this is one where if you're not for sure, look at the example. And so like here, they're doing 7 over x to the 8th, and they're saying the exponent is negative 8, which they're not really explaining why, but that's because of negative exponents and flipping. And it's not a polynomial, so we don't have to put it in standard form. Okay, so is this a polynomial function? Now, it's not in standard form, it's in factored form, but yes, if you think about distributing this, it is a polynomial. Now, what's the degree? So we talked about this. The easy mistake to make would say degree is 1 because that's the largest exponent. But remember, if it's in factor form, you got to add the exponents of your factors. So there's 1 here, there's 1 here, so 1 plus 1 gives us 2. Or if you think about distributing it, x times x gives you x squared. So not only want it in standard form, that means you actually have to distribute it. So that would be x squared, and then minus 6x. With a leading term of x squared. And the constant Well, now there is no constant, so now I know that they're looking for 0. All right, so all that is just kind of warm up questions. Okay. So that's do you kind of understand like some of the definitions, the language, and a little bit about the end behavior, and we're going to come back and do end behavior because those questions are a little out of order. All right, so now I want to do transformations. So what does that +1 do to x to the fourth? Well, it's inside, so it's horizontal. So +1 actually moves it to the left. So bam. And then we need to graph it. And so remember x to the fourth, that's an even degree, so it's going to look like a parabola. And so we said it goes left 1. That looks like that's right 1, that's down, that looks left, that one's up. So yeah, that's right, down, left, up. So C is the only one that moved left. Same idea, just now since we have x to the fifth, we're doing an S shape because it's like x cubed. And so, that one's kind of basic. Let's see if there's any more interesting. What does that -6 do? Well, that's outside the parentheses, so that's going to be down 6. Okay, so what does that negative do? Negative, and it's outside the parentheses. So that's a vertical flip. And so x cubed looks like an S shape. So that's like an upward S shape, so that can't be that one. So it can't be A or D because those are both upward S shapes. Okay, so is it B? So that looks like a downward S shape. Now what's the difference between C? Now if you notice C, it's a downward S shape, but notice that 0, 0 is not at 0, 0 anymore. It looks like it's been moved right and up. Has this graph been moved to the right and up? No. There's nothing else going on other than the flip, the vertical flip, so it has to be B. Okay. All right, so that's what you have to do with these transformations. Okay. And when it's matching, that makes it a little bit easier. Like this one, what has been done? Well, right 6, up 9. So we're starting at 0, 0, and we go right 6, up 9. So it can't be A. That one's been moved left and up. That one looks like it's right and up. That one is left and down. So I don't even have to count because there's only one of these that's been moved in the right direction. Okay. All right. Let's see. So when they do the wording, you just have to be a little bit more careful. Now, remember the 5 is a vertical stretch. So so we know it has to go left 3 and up 2. So left 3. So it might see left 3 up 2. So it might be A. Right 1. This can't be B because it's not moving right 1. Can't be. So even though they have all this wording, the only one that's been moved left 3 is A. So MyMathLab is not very good when they try to do explanations like this. So okay. So that one we haven't discussed yet. Okay. So let's go back, let's back up. Okay, so now let's see, where is this? We're about 15 minutes into this video. All right, so what I'm going to do now is like these are on these are at the end of the notes. So I think this is a good spot to pause and say the end of part 1. And then I'm going to start a part 2 video, and we're going to start with these questions, and then we'll get into the zeros and the multiplicity. All right. That's all I have for this video. Stop sharing. Yeah, I will be back shortly with part 2.